in a variety of products. In the research laboratories, this panel plays a significant role in determining how ingredients will be used. Which new product recipes will actually go into factory production? Being a member of the taste panel is an unusual job and a great responsibility, identifying and charting subtle differences in flavor, fragrance, texture. Of course, some formulations remain unchanged year after year, and the details of all of them are highly guarded secrets. Factory production schedules determine the quantities of specific ingredients that will be drawn from storage on any given day. Since 5 or 6 different types of chocolate may be in production at the same time, scheduling the flow of cocoa beans is especially complex. Beans are withdrawn from the storage silos according to type and origin. In an elaborate cleaning and sorting machine, currents of air and a series of sieves remove foreign matter. Then, they are routed by conveyor belt to a storage tank, which supplies the blending department. Here, proportions for specific recipes are programmed into the automatic blending machines. Each station introduces one type of bean to the continuous flow blending process. Precise quantities are measured in pounds per minute. In an extension of the continuous flow process, the blended beans travel through huge ovens. It's impossible to see inside, but dry roasting at temperatures over 400 degrees Fahrenheit or 204 degrees Celsius develops the flavor and aroma of the beans. Then, in a completely enclosed process, the shell of the bean is removed and the inner meat is broken into fragments called nibs. Nibs of the various blends are transported to specified hoppers which feed the giant triple milling machines on the floor below. The roasted nibs have a natural cocoa butter content of about 55%, which is released during the milling process. The result is a free-flowing liquid. Traditionally, this has been called chocolate liquor, although it has no alcoholic content. All products made in the factory begin with this liquor. However, back before Milton Hershey went into business, it was discovered that chocolate beverages tasted better when the cocoa butter content of the liquor was reduced. So, in making cocoa and cocoa products today, these giant presses squeeze most of the cocoa butter out of the liquor. The butter is drained away and will be used in the making of milk chocolate. The dry cake that remains after the butter is squeezed out is pure cocoa. So the basic difference between cocoa and chocolate is the amount of cocoa butter present. The cake goes through several grinding and refining processes until it's ready for packaging as pure cocoa, or is blended with other ingredients. In another section of the factory, whole milk is being condensed, the first of many complex procedures in the making of milk chocolate. When almost all of the water content has been removed and the milk has reached the consistency of taffy, chocolate liquor and sugar are added, and the mixture looks good enough to eat right now. However, many more steps lie ahead. The mixture gets drier and drier until finally it is conveyed as a coarse powder to another series of mixing tanks. The blending and mixing are computer controlled, and from this console, additional cocoa butter is introduced to make the finished chocolate richer in flavor, creamier in texture. The mixture is now in a liquid state. And from this control center, the flow is directed to one of many conching machines. The name conch began years ago when the machines were shaped like the seashell. Today, there are a variety of shapes and sizes in use. Inside, constant stirring and low heat develop the flavor of the mixture, which is now called chocolate paste. This rotary action conch is preferred for some types of chocolate, while other chocolates benefit most from longitudinal conching techniques. The chocolate paste entering a conch is thick and visibly coarse in texture. In a back and forth or reciprocating action, large granite rollers rub the paste over a corrugated granite base. After 72 hours of conching, this chocolate has reached a rich, mellow consistency with flavor to match. If you were a member of our camera crew, you'd agree that chocolate in the conching stage smells just as good as it looks. But it isn't quite ready for cooling and packaging. Not yet. One final and important operation is required, and these men are preparing to pump the chocolate paste from the conch to the refining department. In the refining process, massive steel rollers reduce the particle size of the blended ingredients, making a fine paste even finer, really velvety smooth in texture. While the chocolate paste is being refined, the peanuts and almonds required for some products are prepared for roasting. After cleaning, an electronic sorting machine inspects all peanuts by color, automatically rejecting any that are below standards. Almonds must pass equally rigorous inspections as they are cleaned and slit prior to roasting. This has got to be one of the most aromatic departments in the factory. Peanuts and almonds are roasted in these stainless steel ovens in an automated process that develops and enhances the natural nut flavor. The result of this special process is a flavor that is deliciously different. A flavor that blends especially well with milk chocolate in the finished product. As the nuts are conveyed to many different departments, the refined milk chocolate paste is cooled to a working temperature of 82 degrees Fahrenheit, 28 degrees Celsius. To make solid bars of milk chocolate, rows of stainless steel molds on an endless belt are filled over and over again during each production shift. The belt passes under two depositors, each filling alternate rows of molds automatically. If an almond bar is being molded, the nuts are deposited in the molds before the chocolate. Throughout the factory, round-the-clock surveillance is maintained by quality assurance technicians. Chocolate samples are delivered to the laboratory for analysis to assure adherence to all quality standards. The performance of each machine is also checked regularly. Here, a sample tray from depositor number 53 is weighed to make sure it is depositing the specified amount of chocolate. The filled molds are vibrated and cooled as they travel through a long tunnel. Vibration of the chocolate, while it's still in a semi-liquid state, helps to assure a solid, well-formed bar with no air pockets or bubbles. At the end of the tunnel, finished milk chocolate bars emerge and move toward the automatic packaging equipment without any human contact.